Okay, let's check our audio. Let's see if we can do this here. Yeah, I don't know. Anyway, that's not what we want to do. We don't want that guy here. Why have that guy in the middle of the picture? Okay. So, good afternoon to everybody here. I'm going to pass back your guys' test you took yesterday, so you guys know. And I just want to let you guys know, it looks like you guys did very well on your tests. So, congratulations to you all. Okay? You did much better than the class, I should say the afternoon class. So I don't know what their story is. Maybe they're afternoon, I don't know. Maybe they're asleep after lunch, I don't know. So it's kind of interesting that maybe classes that meet daily do simply maybe better than classes that meet twice a week. I have no idea. What do you guys think? Anyway. So I'll pass back your exam, but I'll also do, I'm going to upload the solutions in Canvas like I did before, okay? So you guys can verify what you did right, what you did wrong. And I just want to let you guys know I've graded it. As you guys are aware, it's in Canvas already. And congratulations to you. If I had a bag of Flaming Hots, I'd give you each a bag of Flaming Hots, so. It is very wonderful to know sometimes that all the time, energy that I've put in doing those resources that, you know, take away from my life, really, personal life and family life, and you guys name it, all those things. I really enjoy the fact that people benefit from it, you know. So if you benefit from it, good. If you haven't benefited from it, shame on you. You know, taking time from my family. You guys know what I mean? So just to let you guys know, if you've benefited from it, then great. If not, well, you know, you might want to think about what you're doing, you know. But that conversation is more for the other class than it is for you guys. I just want to let you guys know. So I'm going to pass that back. So congratulations to you guys anyway. But for this conversation today, we're going to talk about the binomial probability. Oh, I'm sorry. I made a mistake. We're not talking about the binomial today. Okay, maybe we will. I will. I forgot to give you one other topic. I'll do it tomorrow. How's that? Okay. So remember we talked about a distribution here, okay? What's a distribution, by the way? You guys know it as a table. Remember we did the table? And then we focused on all the language. You guys remember we did the language? Anybody remember that? On what day we did that? No? We talked about language at least no more than for a distribution table, right? So today, though, I'm going to introduce to you guys. Out of order, but that's fine. I'm going to introduce to you guys a way to create those tables, which you really don't want to create a table. Okay, what you really want to create is something different. We're going to give you guys a formula here. So I'm going to go over to Canvas now. Now I got to admit, I have a browser. I hope it doesn't do another picture of me. Good. Who needs that picture of me? We're going to go to the browser. What browser are we in? I don't even know. Where are you, browser? There we are. Okay. Now I'm going to go to my website. And what I'm going to do is I'm going to share with you guys the notes for this, okay? Like I've been doing. Go over all the way to the Statistics Online transition here. And I'm looking for the binomial probability distribution. We still got to talk about expected value. It's going to be tomorrow. So I apologize. I'm going out of order a little bit, not much. But it's okay. Binomial distribution here. So I'm going to put that in the comment section in case you guys go back and watch the video. You guys say you do. Okay. You guys say you do. Is that right? So there it is. But I'm going to share with you a binomial distribution. It's going to be easy peasy lemon squeezy. All right. You just have to know the basics. We're going to go over the basics of the binomial. And, you know, I just want to write down some things, but I just want to let you guys know the notes are there for it. Okay. The binomial probability distribution. Bi meaning, what does the prefix bi mean? Do you guys know? Two. Good. It means two. All right? So it means two. Now, I know you say this is a binomial probability distribution, but this is really a probability formula. Okay? So it's a probability formula that we're going to be using. Okay, so technically, and you say, what's a distribution? Well, it's going to be how you assign probability values to outcomes. So again, x this time here is your random variable. Again, let x be equal, and this is what x is going to be equal to. X equals, we call the number of successes out of n trials. Okay? So x is thought of as successes you're counting. And I don't know what color we're going to use. We're going to use whatever. We're going to use blue. So you're counting successes out of now n trials. And that's a fixed number. N is fixed. And then you have these things called trials here, okay? This is what your random variable does. It counts successes and trials. So let me give you the typical example of a binomial. There's really two examples, and they're analogous. Analogous meaning they're similar to another. So for example, I'm going to say here, I like to say it this way. A couple plans on having five children. Okay? Now, when you read that statement, what you guys should think of automatically is this. How many children does a couple plan on having? 5. Okay. There we go. This is your fixed trials, ladies and gentlemen. That's n. This is n, okay? That's the fixed number of trials. So in this case, n is what? 5. Okay, I'm going to give you guys the most fundamental example of this binomial. You know, it's an interesting, you know, we've been talking about having children, right? We talked about probability questions with having 2 children, 1 child, 3 children. You guys remember that stuff? Say, you know, probability of having a boy or a girl with 1 child, probability of having, you know, 2 boys with maybe 2 children and so on, 3 children. We've worked on that. So I want to let you guys know this is the model that you use when you're going to have more than what? Oh, essentially having any number of children. It's really a binomial situation. But we don't start off with that. We start off with the basics for a very good reason. So we're going to talk about the binomial and how this works. You say bi meaning 2. Yeah, 2 outcomes for every trial. So I know you guys drew tree diagrams and you say, oh, what does that mean? 2 outcomes for every trial. Well, now they're going to ask you the question. They're going to say, A couple plans on having 5 children. What's the probability of having, and here's what's going to happen. Question 1, I'll say no girls. Question 2, 1 girl. Okay? Now, what I want to remark to you guys always, I know when you say this is a random variable x, x is the number of what we call successes, okay? Out of a fixed number of trials here. Which you guys are going to always, always, always do. Did I say the word always? What you're going to always do, ladies and gentlemen, is let x equal what's in the question. Keep your life very simple. What's in the question? Right? Because people say, Mr. Judge, what is a success? What do you see in the question? Having no what? Girls. Having 1 what? Girl. Let x be, or let's let your successes be what's in your what? Question here. See, x is the number of successes? So if I said to you, okay, let's find the value of x now. It's the number of successes. I'll say no. Let it be what's in the question. So you're going to consider a success is of having girls. Girls are your successes. And it's very simple. If you say no girls, how many successes did you have? 0. Good. If you said 1 girl, how many successes did you have? Is that easy? Let your successes be what's in the question. That's a key. If you don't go with that, forget it. You're never going to answer a question. So if they say question now here, number, I would say what? 3, 2 what? Girls. Question 4, 3 what? Girls. Your successes are what's in the what? Question. What's your value of x now? X is what? 2. And what's x over here? 3. Is that easy? Did you guys see my point? Let your successes be what's in the question. So let's go back to what I'm talking about for the binomial. You say, okay, we have n trials. Okay, think of it this way. We can't have 5 kids all at once, right? Here's what I mean. You can't have 5 kids all at once. You're having them one at a time. That's something that people never really emphasize. I do. You're having kids one at a time. You plan on having 5, right? Now, you want to know why this is a binomial? Because for every child, remember the tree diagram? Remember this? For your first child, how many outcomes can you have for the gender? You can have a boy, or you can have a what? Girl. Do you guys remember that? And then we had to go to the next child, and each one, boy or girl for next one, and so on. And you don't want to draw a tree diagram for 5 children. Don't even go there. Don't do that. I've seen people do that on a test. It's like, what are they doing? They didn't do their homework on this. So they want to go back to what they did. And imagine if they gave you 8 children, right? Would you do a tree diagram for 8 children? How you doing? How about a tree diagram for 10 children? 12 children, a tree diagram. What do you guys think? Isn't that crazy? Just learn the binomial. Now, you say, what is this, Mr. Judge? This is called a single trial, meaning one trial. That's going to be important for us. But my point is, the word binomial comes from the fact that for every one of these 5 trials, you're going to have either a what? Boy or a girl. Is that true? You guys see my point? 2 outcomes for every trial. For the second trial, you can have a boy or a what? Or then a what? Boy, girl, right? Those are the gender possibilities. There's only two. This is why we call it a what? A binomial distribution. Two outcomes for every trial. Two outcomes. Okay? You guys okay with that? I'm telling you, ladies and gentlemen, this is easy stuff, but you got to do your homework. Let me say that again. I know I have to have this conversation with the other class, not you guys. But I'm going to tell you, I'm going to say it, I'm going to say it, I'm going to say it because, God put me on this earth to say it. That's how I really think. You're crazy, Mr. Judge. Yeah, who's crazy to do all those darn resources? Should be really with his family. You guys know what I mean? Should really be doing his hobbies, relaxing. Man. Here's the deal, right? If you're consistent with your homework, you do that stuff every day, it'll change your life. If you make it a priority, it'll change your life. I know, because it changed my life. I can say that to you guys. Made it a priority, did it every day, and you know what? Now things became possible for me. And, it took some growing up, I got to admit. I had to grow up because I didn't even want to even go to the library. I was like, what? Library? Who does that? Eventually, I lived in the library. They could name the library after me. Went there early in the morning, left late at night. Because if I went home, what would happen? Forget about it. If you go home, what happens? There's all kinds of distractions. You got the Xbox, the PlayStation. You got the refrigerator. You got that bed. Oh, my God, that bed that's calling my name right now. What else do you guys have? What else do you need? You got Netflix. Well, you could get it on your phone now, so that's a problem. Yeah, that's a problem because if I go to the library, I just might get on my phone on Netflix. Sometimes I think we got to throw our phones away. What do you guys think? I think so. We got to throw those iPhones away. Such a bad distraction. We got so much ways to be connected and we're all disconnected. Isn't that the irony? You can connect, but yet what's the irony? We're disconnected. Oh, man. We didn't have tutoring back in the day. We didn't even have video resources. We had nothing. Oof. Anyway, I won't sound too much like an old man. But I sometimes wonder. Anyway, what's my point? Do your homework what? Every day. It'll change your life. Trust me on that. If you start doing your homework at the weekend before your test, good luck. Even some people the night before, I'm laughing. I'm on the other end of this canvas. You guys know on my phone we're connected. And you're like, the night before, hey, Mr. Judge, I started my homework. I forgot how to do everything. Is there a video that you can tell me how to do everything the night before a test? I've never made that video. How to succeed. Oh, my God. I'm getting ideas. How to succeed the night before a test. You know what? I'm going to do that. I'm going to make that video. It's going to be like clickbait. How to succeed the night before a test. And then I'm going to get on that thing. I'm going to say, you can't. Everyone's going to go, what? Everybody's going to want to watch that video, right? I'll put it out there. How to succeed the night before a test. You can't.
Just make it long. And only for the end, just say, oh, you can't.
I don't know. I think I'll probably lose people the first few minutes or so, Yeah, I'm going to say, you know what you do the night before a test? You should have me sleeping. I'm going to say you sleep. Man. Yeah, put me in Maui. Oh, my God. Don't even get me started. Oh, don't even remind me. Oh, shoot. Don't remind me of that either. Oh, my God. I should be working on my business. What am I making videos for you guys? What the hell am I doing? I should be working on my business. Going to business for myself. Making videos. Nobody's watching them. Nobody's doing them. You guys know what I mean? Sometimes wonder. Anyway, what's my point again? I forgot. Do your homework. Do your what? Homework. Every day if you have to. I was that kid because I know I would forget. Like, oh my God, I'm going to forget. So I do my homework. Sometimes, this is crazy. I'll tell my calculus students, I got to talk to them. I got to talk to everybody. Sometimes I do my homework twice. I know, it sounds crazy, right? You go, why'd you do your homework twice? Because, sometimes you do your homework, you think it didn't stick. After you finish, you go, how come it's not in my brain the way I want it to be? It just didn't seem like it stuck. Then, some topics, I did my homework 3 times. Some topics, I did my homework 5 times. I'm remembering like a calculus course. I was a kid doing chain rule for derivatives, U sub, and blah, blah, blah. I had to do my homework 2, 3, 4, 5 times. And then it stuck. Who does that? Isn't that crazy? Sometimes you got to do it, ladies and gentlemen. It's the way you do it. It's how you survive. It's how you do it. Anyway, that's how you do it. I'm going to tell you guys the truth. There is no shortcuts. The world is looking for shortcuts. And there is no shortcuts. There just isn't. I wish there was. Anyway, I'll show you some shortcut today. Do your what? Homework. Why is this a binomial situation? 2 outcomes for every trial. See this? The first child, you can have a boy or a girl, 2 outcomes. Second child, boy or a girl. Third, boy or a girl. Fourth, boy or a girl. Last, boy or a girl. Binomial. Good. You're almost there, ladies and gentlemen. We've done the language. Let the successes be what's in the question. No girls, X is 0. 1 girl, X is 1. 2 girls, X is 2. 3 girls, X is 3. And then go to this idea here, the single trial, ladies and gentlemen. This is also the key here for any binomial distribution. This is going to be easy for you guys. It's going to be easy. You're kind of downhill with the course at this point. In some ways, you're kind of downhill. But it depends on you. Again, this conversation is for all the other students. I got to warm up with you guys. So, because I got to talk to the trick students, but I wasn't awake. And I got to talk to the calculus students too. You got to talk to everybody. What was a success in this question? Having what is a success? In the question. Having a what? A girl. Remember this? That let the successes be what's in your question. Because the random variable is your random variable X counts successes, number of girls in this example. So if they asked you a child question with boys, what's your success there? Having what? Boys. Don't look into it. It's simple. Don't say, I like girls. I mean, listen. I have daughters. I love girls as daughters. Not every dad can be a daughter dad. I'm a daughter dad. But I'm sure if I had a son, I would be a son dad too. So I'm not looking into it that way, okay? Don't look into it that way. Go, what do you mean? What's a success? Yeah, you're counting what's called successes in these questions here. It's always going to be what's in the question. So if it's boys, well, then it's boys. That's your success. If it's girls, well, it's girls. And you'll see different examples. Okay? So, okay. Why is that important? Because what's the probability for a single trial, ladies and gentlemen, of having a what? A girl. That's going to be important because I have to define for you this thing called little p. Little p, this is the probability of a success for a what? A single what? Trial. So we need a success for a what? Single trial. What is that value? What's little p? What do you think little p is? You guys know. What's the probability of having a girl? That's what they're saying. Little p in this question is the probability of having a girl when you have one child. That's what single means, one child. So what's that chance? 1 out of 2. That's 1 out of 2 as a decimal, which is what? 0.5. So, ladies and gentlemen, it's 0.5. When you work with a binomial distribution, we're going to work with the what? TI calculator. Okay? To answer a binomial question for the TI, we just need what? 3 things. You guys ready? You need n, x, and little p. N, x, and little p. Because what you're going to be using is binom PDF. Remember what I did here for you guys. This is in the TI here. We got x. We got n. I'm going to color little p a different color. Let's take purple, I guess. We like purple. Or do you guys like pink? Purple or pink? Pink? Okay. Pretty and pink again. You guys remember? Pretty and pink. So for this question here, I'm going to copy this here. For this question, we're going to do the following here. We're going to compute the probability of having no girls. This is known as P of x equal to 0, which is really what? P of 0. So we're going to do the probability of having no girls. We're going to approximate to the thousands here. Okay? And I'm going to share with you guys how to do this with n, x, and p. You already know what x is. What's x? 0. Good. What's n? Did you guys forget? How many trials are we having? 5. Good. What's little p? Pretty in pink. P is what? 0.5. So we have x, we have n, we have p, we have the TI calculator. The TI calculator, ladies and gentlemen, is back. Let me find it. I can't find it. Where are you, TI? Whatever. I have to move this. Here we go. Okay. There we go. TI is back. Do you guys see it? Now, you're going to access, that's kind of weird, but you're going to access the binomial distribution formula in this calculator. And in order to do it, I'm going to kind of scroll in, I guess. Let me see if I can scroll in. Could you guys see that there? Anyway, I can't see it, but whatever. I'm going to go here now. I'm going to go to what? Where do I go? Stat? No, I don't go there. Oh, I know. I got to go to the distribution list. You see that vars key that's there? Let me scroll in. You see vars? Above the vars key, it's blue. That's called the distribution key. I got to go there. So I'm going to go second, distributions. Now I have all my distributions listed. I got to go to the binomial PDF, binomial probability distribution formula. And it's actually all the way down where? Oh, there we go. It's what? It's an A. It's A. Do you guys see that there? All right. Hit enter. And guess what? What does it say? Trials. What's your trials? 5. Good. What's our pretty in pink little p? 0.5. Good. And then what's the value of x in the question? That's all you do. Okay? That's all you do. Hit what? Paste and hit enter. There it is, ladies and gentlemen. Approximate this. Yes.
Would it be the same for TI-83?
It should be. Should be. 0.03. What is that? Is it 1 or 2? Go into the thousandths. 0.031. Okay, ladies and gentlemen, guess what? You've answered your first binomial probability question. This is the probability of having what? No girls. So, is that easy or is that hard? Well, maybe the first example you see, you say, boy, this is a challenge, Mr. Judge. Let's go to the next one. What's the value of x in the next one? You're having how? They're going to know what's the probability of having what now? 1 girl. You guys okay with that? All right. Chance of having 1 girl now. Isn't this easier than the tree diagram? Say yes. Okay. Good. All right. So here's what we do. P of 1. What's the probability of having 1 girl? What do you have to change now here? Your x value is now what? 1. So let's go over to the, here we go. Practice this. You say, okay, get to the distribution. Second, vars, that's the distribution list. Scroll to binomial, which is actually A. Hit enter. What's your value of x now? Is that 1? Scroll down and hit paste. Ladies and gentlemen, oops, sorry. I didn't share with the audience. You guys can't see that. Let me do that again. I'm going to clear. Second distribution. Scroll down to binomial PDF. Okay, binomial. Change the value of x to now what? 1. Paste that in. Hit enter. And give me the answer to the tenths. What's that going to be? Point what? 0.156. This is the probability of having what? 1 girl. Okay? 0.156. So that means, just so you guys know, 15.6% of couples that have 5 children will have 1 girl. 3.1% of couples that have 5 children will have no girls. So that table that I created for you guys last time, this, for some of the distributions, for binomial distributions, this is what they use. Number 3, 2 girls. What do we say x was in number 3 here? What's your x? 2. So, in the TI calculator, to find P of 2 now, what do? We have to change that x to what? 2. So we're going to go second distribution, go now down to binomial PDF. There you go. What is this? 2. Paste that in. What's this to the nearest tenths? I'm sorry. Thousands. 3, 1, what? 3. Is that true? So, ladies and gentlemen, this is the probability of having 2 girls when you have 5 what? Children. And then that corresponds to 31 point what? 31.3%. Okay? Question 4. Having what? 3 girls. We're trying to find P of what now? P of 3. Is that true? So how do you do that? Go now down to what? Second distribution. Scroll down to binomial PDF. Okay. What's your value of x now? 3. What do? Paste that in. What do you get? Oh, it's the same answer. 0.31 what? 3, ladies and gentlemen. 313. All right. I'm going to do this to you guys. I didn't ask that, but I'm going to ask you guys now. What's the probability of having 4 girls? What's the probability of having 5 girls? So what is the value of x here? X is now going to be what number? And then x is going to be what out here? You guys okay with that? Okay. N is still 5. We're still having 5 children. Little p, probability of a success is 0.5. Okay. So let's find out what this is. P of 4, and then we're going to do P of 5 here. Okay? Easy peasy, lemon squeezy. Go to the TI, okay? And you're going to go now here. You do what? Second distribution binomial PDF. Hit that enter. What's your value of x now? 4. Paste it in. And what do you get? What is this? 0.15 what? 6. Is that true? Is that easy? All right. How about P of 5 now? Second distribution. Go to the binomial distribution. And what do you get now? Change that x value to what? 5. Hit paste. Ladies and gentlemen, what do you get? What is this going to be? 0.03 what? 1. So this is really, ladies and gentlemen, what you need for any binomial question. You need what? In the TI. N, X, and what? P. Easy peasy lemon squeezy. Anybody have any questions? What do you think? What I'm saying is the course is kind of downhill in some ways, because now it's really turned into, if you guys remember, I give you guys that TI summary sheet. Do you guys remember I gave you guys that? And then you might see, boy, Mr. Judge, there's a lot of this summary in the TI. There's a lot of things in that TI there. Oh, there is. But now you're going to make more use of that summary sheet. Okay, do you guys know what I'm talking about? And so in some ways, it's just going to be now you and the TI calculator. You guys just focus on the language and the questions, and there it is. But you want to practice it. You never want to do this the night before or the weekend before. The night before, go to the movies. Have a good time. You know, I wanted to go see John Wick 4. Anybody see John Wick 4 yet? Oh, did you like it? Was it any good? Did you like John Wick 3?
Yeah, I like John Wick too. Yeah, I was compared to Sour
Oh, but you did like John Wick 4.
Yeah,
It was good.
yeah.
Do you guys like the John Wick movies?
Yeah, I don't like the dog dying in the first one, but I like that he gets revenge.
Mm. Well, she's talking the first one. The first one. You know what's interesting to me sometimes is, nah, I won't even go there. But yeah, night before a test, man, just watch John Wick 4. Have a nice dinner even, and then get a good night's sleep. But you say, but Mr. Judge, when am I supposed to study and do my homework? Now. This is when you guys study. Now, this is when you do your homework. Now. Because what if it takes you, a few days to understand what you're doing? It might take 3 days. It might take 4. The night before, that's not enough time. It's a little secret to success, ladies and gentlemen. Don't tell anybody. I'm going to make my YouTube channel a pay channel. So I can tell people these little tidbits. And then you get to tip me or something. No?
People already kind of tip you on YouTube already.
They can?
Yeah, I've seen some people where they kind of give some offers to some channels where,
Some channels do that.
yeah,
I-
I think a certain subscriber level maybe.
Well, I can't do that. Actually, technically, I can't do that. I can't charge you guys that. I can't charge you. Darn it. Wish I did. I can't take tips.
Members only videos.
Yeah, I don't know. Maybe I have to redirect you to a subscription.
Patreon.
Can't do that. Can't do that either. I need board approval before all those kind of things. And they'll never approve it because it's against board rules. I can't charge you guys. Darn it. Anyway. How about this question? You guys know my favorite questions. At least one girl. How would you answer this at least one question? What's the meaning of at least one? X is what? Greater than or equal to 1. Is that right? Isn't that 1 or more? Let's see if you guys remember. How do I answer this question by definition? Yes, I can say P of 1 plus what? P of 2 plus P of 3 plus P of 4 plus P of 5. Is that right? Because this is the meaning of at least 1. But what would I use? I'm not going to use that. What am I going to use? See if I miss my sound effects. What can I use? What's it called? Complement rule. What do? 1 minus P of what? 0. Use the complement rule, ladies and gentlemen. This whole thing. Isn't that faster? That's faster. So let me share with you guys how that's even done in the TI. Can I show you guys? Okay. Here's what you guys can do in the TI. Let's go to the TI now. I'm going to clear this out. I could do 1 minus what? P of 0. Go to the distribution binomial. There we are. N is 5. Little p is 0.5. What is the value of x now? 0. Change that to 0 and paste that in. Do you guys know what you're looking at? You're looking at 1 minus p of 0. You're looking at this right here. You're looking at the complement rule. That's your shortcut. So whatever I get when I hit enter now in my TI, this is going to be what? 0.96. 96 what? Is that 8 or a 9? 9. 0.969, and ladies and gentlemen, here you go. You are what? Done. Could you have added P of 1, P of 2, P of 3, P of 4, P of 5? Yes, but what did I use? The complement rule, ladies and gentlemen. In fact, take a look at number 8. Probability of no more than one girl. What's the meaning of no more than one? X is less than or equal to what? 1. Did I give you guys that language sheet we worked on? No more than 1? Oh my God, I got to find all these things. That's even in your notes. You guys worked on language. So the definition here, what's my definition? I have to add P of 0 with P of what? 1. No more than 1. P of 0 plus P of 1. Okay, you guys okay with that? Isn't that the meaning of no more than 1? 1 or less. What does the TI say? You say, where's that TI? Okay, TI. Second distribution, or VARs. Binomial PDF. Oh, I already have the P of 0. Paste that. Now add it with what? P of 1. What do I have to change? Change X to now what? 1. And then paste that in. So what you guys are looking at is P of 0 plus P of 1. That's exactly what we need to do. Is that true? Hit enter, and what do you guys get? Point what? 1, 8, what? 8, ladies and gentlemen. Okay? This is what you need to do. 0.188, no more than one girl. What do you guys think? Is that okay? Easy peasy lemon squeezy? What do you guys think? Now, let me go back to my website because, like I said, some of you guys, maybe you haven't even looked at this. You go, oh, my God. Anyway, this is going to be the notes on the binomial, but where's what I'm really looking at here. If you guys remember, on 227, I did, where is that here? Statistic summary sheet. I'll even put that in the comment section in case some of you guys go back and look at the video. You guys tell me you do that. I don't know, but you say you do. Do you guys do that? Maybe? There we go. So let's go back to the... Did you guys see? You know what I even did? I even put what? I even told you what... I put like a table of contents. Formulas, 2 to 3. Key phrases, 4 to 5. TI 84 plus CE calculator summary sheet, 6 to 15. This is my point to you guys. Here's some of the formulas. I might update that as we go along. Okay, you go, oh, formulas. Oh, key phrases. At least a. Oh, we have those in the inequalities. Is that right? Maybe we should color them red or something. No more than A. Oh, more than A. Less than B. No more than B. X is less than or equal to B. I even got your key phrases summarized for you guys. Some of this language we're going to see later. That's why I did it. And then, oh, we got to look for all these. Okay, we already know that. What are we looking for? Oh, no. There we go. Binomial. Did you see the summary sheet? And then what's coming next is you'll have the Poisson. And then after that, you have the normal distribution. And then working backwards with the normal distribution. So, ladies and gentlemen, as you guys can see, it's becoming a TI course with language. And that's my point to you guys. So I did put that there for you guys, okay? That's what we're working on. Do you guys think it's doable? I think it's doable. Number 9. What if they said you have more than 3 girls? What's the chance that you have more than 3? Do you know the meaning of more than 3? X is the number of girls. How do we describe more than 3 girls? X is what now? Good. Greater than 3. Outstanding. So you'll say, okay, can you guys tell me which of the outcomes are more than 3? Well, it has to be more. P of 4 and 5. Exactly. Okay, you guys okay with that? Aren't those greater than 3? Is that greater than 3? You got to know the meaning of more than 3. So when you go to McDonald's for lunch, what do you guys order? They say, what would you like? You tell them, give me more than 3 Big Macs. Give me no more than 2 orders of French fries. Give me at least 5 orders of chicken nuggets. What do you think's going to happen? They're going to freak, aren't they? But why do I say that as a joke? Because you want to get this in your language. You want to get this in your vocabulary, your thought process. And so, you want to think of it that way. And this is kind of a way to get it in there, I think, in some ways. Okay, you guys know what I mean? What do you order at McDonald's anyway? What's the best thing on the menu at McDonald's? McChicken. The which one? McChicken. Are they spicy one? The spicy McChicken's the best thing? Is that you agree? The spicy McChicken, huh? Is it better than the Popeyes chicken sandwich?
I only tried it like once.
What about Jack in the Box spicy chicken?
Yeah.
That was the original spicy chicken, in case you guys didn't know. They started it all. Jack in the Box with that spicy chicken sandwich. It was at Jack's. They started it. Now spicy chicken's everywhere. Where's the best spicy chicken? Gotta remember that place. It's pretty big now. They just knocked it out of the park. No, what's that Tennessee hot chicken sandwich? Where it started out there by Dodger Stadium in Chinatown? No. What is it? Helen Ray's. They started it all. Well, they didn't start it all. Jack in the Box did, but I think they took it up a notch. Like, they took it up a notch. Helen Ray's. If you guys don't know. Anyway, like I said, I have a daughter and she likes to grub. Hey, what happened? You got to go to the TI. You don't go to... What happened? There you go. Let's do P of 4 plus P of 5. Second distribution. Go to the binomial PDF. X is what number? 4. Okay. Plus what? Second distribution. X is what number now? Yeah, just change the X value. So change X to 5 here, okay? And paste that in. So you're looking at P of 4 plus P of 5. Literally looking at it with the language of what? Binomial. Hit enter, and what do you get? What is this approximately? 0.18 what? 8. So ladies and gentlemen, 0.188. Easy peasy lemon what? Squeezy. I'm telling you, not too bad. Not too bad. Okay, number 10. How about this one? What's the words? More than, no more than, at least. How about if they said you have less than 2 girls? You got to know the meaning of less than 2. Okay, x is less than 2. It's even on the summary sheet. So how would I, ladies and gentlemen, find that out? What's the definition of less than 2? P of 0 plus P of 1. Is that right? Is less than 2, do you include 2? No. Less than 2 means just exactly that, smaller than 2. Okay? So now in the TI, I'm telling you, this is downhill. People don't realize that. Second distribution. Do we have any people who want to quit yet? No. It's downhill, like I said. Probably not this class. I'm going to have to talk to the next class. Tomorrow, the afternoon class. What's x? 1. P of 0 plus P of 1. That's what you guys are looking at. What do you get? Oh, point what? What is that? I think I got to go back to my blue. 0.18 what? 8. Okay. Easy peasy what? Lemon squeezy. What do you guys think? Can I change this on you guys? Give you another example? Give you guys another example. See if you guys learned anything here. Okay. Example. A couple plans on having 8 what? Children. What's the probability of having question 1 less than 3 boys? I really changed things on you guys here. Okay? I really, really changed it on you. Let you guys write that down. Give you a few seconds to chew on that. Okay. What did I just do, ladies and gentlemen? What's the first change? N is what? 8. That's the number of children. That's the number of trials you're going to have, okay? Here's my N. And then, what else did I change? What are your successes? Yeah, having boys, okay? Now we're having boys. Less than 3. That means x is less than 3. Maybe I'll color coordinate that here. What is little p? That's the probability you have a boy for a single trial. Remember that? A single trial. What's that probability? It's still 1/2. Is that right? 0.5? So, ladies and gentlemen, it's still going to be 0.5. So you guys know that. You say, why? Well, go back to our tree diagram. Right? The probability of having a girl, yes, is 1/2 for a single trial. The probability of having a boy is also 1/2. These are said to be equally likely. Okay? And I don't know, what did we do? I think we changed that to pink, right? And I did purple. These are said to be equally likely. Okay, sometimes with two outcomes, they're equally likely. Not all the time, sometimes. So little p is going to be the same. Just want to go share with you guys that little detail, okay? All right. So you say, Mr. Judge, I need what here? Yes, you need n. It's 8. You need x. Well, we have that. You need little p. We have that. So in this case, x less than 3. What's the definition? P of 0, P of 1, P of 2. Why, ladies and gentlemen? Why? Are those the outcomes that are less than 3? Less than 3 being 0, 1, or 2? What do you guys think? Is that true? Okay, so the rest is all TI now. So let's go to our TI. Second distribution. Oh, I'm sorry, I hit clear. Second distribution, go to the binomial. Number, there we go. N is 8. Little p is the same, is that right? We're going to start with 0. We're going to be consistent here, starting with 0. And then we have to add what? P of 1. Is that true? So there's P of 0. Second distribution. What happened? Trig. Okay. Second distribution, binomial PDF. Change x to what number? 1. Paste it. Add it. Second distribution, change your x to what? What's your x value now? 2. What do you do here? Paste that. So what you entered, go back to the TI, you're doing this. P of 0 plus P of, let's move it. P of 0, P of 1, P of 2. Hit enter. What do you get? 0.14 what? 5. So, ladies and gentlemen, there you go. So, they're going to change the number of children on you. They're going to change what is a success, and what else are they going to change? The language. Number two. How about at least 2 what? At least 2 boys. Right? We're in the boy mode. Anybody here have any boys? How do you like those boys? 1 boy. 1 boy. And 1 girl? Which do you like better, the boy or the girl? Okay. Do you have a girl?
Yeah.
Which one do you like better, the boy or the girl?
The girl is more active than the boy.
Isn't that ironic? Sometimes those girls are what? No, they're what? I have 2 girls. One is, I would say, what? I'd say she's a diva, but she probably wouldn't climb on the table and jump off it. One daughter would. She'd climb on the table and jump off it. I don't know. One is hyperactive and the other is not. It's interesting. I never thought that was possible, but it is.
I have 2 boys. The little one's more active than the older one. The older one is calm. And the little one's.
Does it usually happen with the little ones, you think? I'm just wondering, is it a consequence of being the older and then the younger sometimes? I don't know. Isn't that interesting? I wish I had some data on that. The hyperactiveness in relation to the order of the child. Is there any older children in the room that you're the hyperactive one and the younger ones are not? Oh, is that?
Well, my younger sister is in she's calm.
And you're the hyperactive one?
Yeah.
You seem a little calm to me.
Yeah, sometimes.
Sometimes. Are you going to jump off the table?
Yeah. I broke my arm when I was a kid and I jumped off the chair. I was 3 and I broke my arm. So.
Oh, a 3-year-old? Oh. Well, I got to think about this. Me and my brother. I guess I don't. Yeah, I guess we were older though. We used to ride our bikes and jump off stairs. Oh, does that make you hyperactive? As a boy, ride your bike. You ever jump off stairs riding your bike? Anybody do it? Know what I'm talking about? Not writing down. I'm trying to remember. I think we were trying to jump the stairs. We thought we were Evel Knievel. You probably even know who Evel Knievel is. But back then, when I was a kid, Evel Knievel was pretty amazing. Huh? Yeah, but we jumped off the stairs, and I know I made it, and my younger brother didn't. And he ate it. I thought we lost him. I was so scared. You're like, uh-oh. What does at least 2 mean? So I put x is greater than or equal to 2. You start at 2, is that right? So, okay. We'll start at 2. Then you add what? P of 3 plus P of 4. P of 5. P of 6. My God, P of 7. P of 8. Oh my gosh. Take a look, ladies and gentlemen. I'm going to say this to you guys. This is why I illustrate the complement rule and why I compare that to the definition. Why do I do that? Do you guys know? The complement rule is always 1 minus the probability of the outcomes that are not here. Can you guys tell me which outcomes are not here? What's not here? 0. What else? 1. What do we call this? Complement rule. So all I got to do now is this. Go to the what? The TI and use the complement rule. Say 1 minus second distribution. Go to binomial PDF A. And it's still 8. Little p is 0.5. Now we're going to put p of what here? 0. Paste that in. Make sure I do a what now? Minus, good, second distribution. P of what now? 1, good, hit paste. What do you guys get? What is this? We're going to the nearest thousands. 0.9 what? 65, ladies and gentlemen. There you guys go. So, here's kind of an interesting thing, and I want to emphasize this idea too, is that this is like a 96.5% chance, right? It's a 96.5% chance that you'll have at least 2 boys when you have what? 8 children. Couples that have 8 children, it's a 96.5% chance you'll have at least 2 boys, meaning 2 or more boys. So this is kind of something that people really care and think about. This is how you use that logic. What about no more than one boy? Maybe you're you got a real preference, sorry. You want to know no more than one boy, no more than one. What does that mean to be no more than one? It's one or less, so x is less than or equal to 1, okay? What's the definition of less than or equal to 1? Isn't that p of 0 plus p of 1? Did you guys notice the language part? It's always going to come back, that language. This phrase, by the way, is my favorite phrase with my daughter. Why is that my favorite? Do you guys know? What do sons ask for when you go to the store? Everything? They ask for everything too? Well, what does your son want when you go to the store? Toys? You know what you can tell him? You can say this. You can get no more than one toy. That's my favorite phrase. No more than one. Why? Yeah, you can say, does that mean they get one? Not necessarily. They can leave with what? None if they don't find anything they like. So it's p of 0 or p of 1. Remember the or is the addition rule? Or. You guys see how that works? That phrase, no more than one? Okay. Maybe your kids want cookies before dinner. What do you say? No more than one what? Cookie. Who eats the cookies, the boys or the girls? Boys? Oh my God, my girls. My daughters. One daughter, she'll have the cookies. The younger daughter will. The older one won't. Just goes to show, kids are different. Second distribution, I go to what? X is what? 0. Paste that. Plus, this is p of 0. Second distribution, p of what? 1. What do you end up getting here? What is this to the nearest thousandths, ladies and gentlemen? 0.0 what? Is that 0.0? 035? Man, and then my little iPad pencil. Oh, sorry, 0.035. Anyway, ladies and gentlemen. Okay, let me do this here. Come on. So at 3.5% chance, you'll have no more than one boy, one or less. All right, I'm going to pass back your test, ladies and gentlemen. Okay. There we go. Oh, now there's an echo. Not sure what that deal is. You don't want monitor. All right, whatever. Not quite sure. I'll figure the rest of that out. Okay, ladies and gentlemen, let's see what's going on here today. Let's go over to the browser here. So to remind you guys, we have some test solutions I posted for you guys, okay? It's down here under study guide and test solutions. So, I passed back your test yesterday, and you guys, I promised you guys some test solutions. So what you guys can do is look that over, please. see where you went right, see what you did right, see what you did wrong. So there we go. You got some test solutions here you can look over. And I think you need to, where are we at? Yada, yada, yada. Go to the browser. There we go. So what I'm saying, since you didn't see me do that, your test solutions have been posted. They're down over here. Okay? So what you guys can do, like I said, review what you did right, what you did wrong. There's like 53 or 54 check marks. I think it's 53, looking for 53 things. So review what you did right, what you did wrong. And there you go, ladies and gentlemen. So I did post that for you guys this morning. And I hope you guys enjoyed that exam. Okay? But anyway, there we go. There we go. Let's go back here. All righty. Okay. So here we are, ladies and gentlemen. Here we are. So yesterday we started the binomial distribution. Is that true? And we started with a classic setting of having children. And we were using the TI calculator yesterday as well. Okay. So what I'm going to do is I'm going to give you guys another example here. Okay. I want to illustrate to you guys an important point in this example. I'm going to say you're going to take a multiple choice quiz. Okay. So they're going to say this. You're going to have an 8-question multiple choice quiz in which every question has 5 possible answers. So I want to share with you guys how this works with the binomial. Okay. Now, when you say, what do you mean has 5 possible answers? Yeah, answers like A, B, C, D, and E. Does that look familiar by any chance, ladies and gentlemen? Okay, so here's what I'm setting the table here. So what I'm actually saying to you guys is, like, for example here, you got question 1, okay? You go, here's the question, and then you have A, B, C, D, and E. Those are 5 possible answers for you. Question 2, here you go, and you have what? A, B, C, D, and E. All the way down to question 8, okay, we have A, B, C, D, and E, okay? So this is what this is so far. I'm going to share with you guys how to approach this by a binomial distribution question. So I'm just setting the table with a question. They're saying you have 8 questions on this multiple choice quiz. Each question has 5 possible answers. Does that kind of look like a familiar situation? Do you guys know what I'm talking about? You ever take a multiple choice quiz? Yep. Okay. So here's what else is happening. You didn't study on this quiz, and guess what happens? You're going to guess on each question. I guess on each question? Yes. Has that ever happened? You took a multiple choice quiz, you had to guess on every question? You guys know what I mean? That's what they're saying. You got to guess on everything. Yikes. So you can guess on every question. Okay. So here's what I'm going to say. Let me see about how to word this. What's the probability of question 1? Well, here's what they say. What's the probability of question 1? No correct guesses. Okay. Question 2. 1 correct guess. Question 3. 2 correct what? Guesses. Okay, just going to compare and contrast this situation. This, ladies and gentlemen, is a binomial probability distribution. Okay, this is a binomial probability distribution. Now, what do we have to identify, ladies and gentlemen, if it's a binomial? We need 3 things, right? What do we need for a binomial? Do you guys remember? We need what? N, we need X, and we need little p in order to do this question here, okay? This binomial probability distribution. N, X, and what? Little p. So how do we do that? How do you guys think? What do we do? What is N? What do you guys think N might be? Remember the definition? N is the number of trials. So how do we think of this situation? Yeah, the 8 questions are your what? That's N. Can't remember. I think we used red. Is that true? So yesterday, in other words, the number of what? Questions is the total number of trials. N is 8 here, ladies and gentlemen. Okay? Because it's like thought of this way. You go, oh, I'm going to go through a binomial situation, 2 outcomes for every trial. So I'm going to have 8 trials because there's 8 questions. So I answer a question 1 at a time. Is that true? So they're all done 1 at a time. So I'm going to answer that question 1 at a time. Okay. So how you guys doing at home where it's nice and, is it warm and cozy? Those people who are at home, do you guys know what I mean? Let me see, where am I? I think I could do this. Where is it? I'm going to add. Yeah. No, I don't want to add that guy. I don't want him. How you guys doing? Get rid of that guy. Let's get rid of him. No. What do I want to do? There we go. That's what I want to do. Mr. Judge's hair got wet. So these are the people at home. Look at that. They're staying home because it's nice and warm at home, right? And what do we have to do? We got to be here where it's cold. Anyway. Okay. There we go. So I guess you guys didn't know I can do the comments, bring the comments in, right? I need my sound effects, though. We got about 7 people at home today. My hair is all wet because of the rain. So N is 8. What if there was 10 questions? What would N be? 10. You got 10 trials. You got 10 guesses. In other words, you're going to guess in every question. What if there's a 12 question quiz? N is what? 12. You guys see what I'm saying? So there's N is 8. There's 8 trials. So you go, okay, this is going to be 8. Good. And then what is X? Do you guys remember the definition of X? X is the probability of a success out of those 8 trials. What's a success? What do we call a success in this case? The successes are always in the what? Question. Didn't we say that yesterday? So notice this. No correct guesses. What does this say? 1 correct guess, 2 correct guesses. What are your successes, ladies and gentlemen? Always what's in the what? Question. What is X? X is defined to be the number of what? Correct what? Guesses. Whatever is in the question is your successes, ladies and gentlemen. That is what you're counting. So now here, if they say no correct guesses, what's X? Is X 0? Good. What about 1 correct guess? You're counting correct guesses out of the 8. 2 correct guesses. X is 2. So we're counting correct guesses when we have 8 trials. You guys see how that works? Easy peasy lemon squeezy. You guys with me on that? So good. Correct guesses is what we call a success, whatever's in the question. Now, what is little p? Remember little p? We're going to have to go. What was the definition of little p? That was the probability of a success for a single what? Trial. Now, this is a binomial here. 2 outcomes. This is that single trial. Now, we're going to have to think. Single trial, 1 trial. What does that mean, ladies and gentlemen? What are you doing here? See that question? Question 1. What are you guys doing? It's not having a child. It's what? It's guessing on a question. Little p is the probability of a success for a single trial. Probability of a correct what? Guess. That's what little p is. So remember, you can either guess correct on the test, is that right? Or you can guess what? Incorrect. You see how there's 2 outcomes? There's 2 outcomes for every question. This is a binomial. 2 outcomes for every trial. Either you guess correct or you what? You do not guess correct. That's an incorrect guess. 2 outcomes. The success is here is guessing what? Correct. And I think we colored it pretty in pink yesterday. Pink. So could you guys tell me, for little p, what's the probability of a correct guess? Ooh, I'm not going to help you on this. This is your domain. You guys are students. You take multiple choice tests probably all the time. Is that right? All the time. Do you guys take them? Then you should know this. If you have 5 possible answers, how many answers are correct? Anybody know how many answers are correct? Like for the first question, what's the correct answer? Oh, let's say it's what? B. You guys okay with that? Could you guys tell me what's the probability you guess correct on that first question? That's the key. What's that probability? I wish I had my sound effects. 1 out of what? 5. That's the chance of guessing correct. Because there's 1 correct answer out of 5 possible answers. Does that make sense? So that probability is what? 1/5. What's the probability of guessing incorrect, by the way? What's the complement? 4/5. So what I want to say to you guys, and write the decimal, isn't that 0.2? Okay? What I want to make clear for you guys is this extremely important detail. we also say this. This is little p, by the way. This is called little q. Little q, well, that's the complement of p. So q will be 1 minus 1/5. And then we replace that 1 with 5 out of 5. We've been doing this a lot. So q is 4/5. Now, here's the reason why I gave you q. That's the probability. That's the complement. Okay? Here's the reason. A lot of times people think just because you have two outcomes, they're equally likely. No. This is the case where P does not equal Q. This is not like having kids. Probability of a boy for a single trial is 1/2. Probability of a girl is also 1/2. Is that true? But you don't always have equally likely outcomes for a binomial. This is the classic example. Just because you could guess correct, it's not a 50-50 chance on a 5-answer multiple choice. What? This is the key, 5 answers. So, you could do this all day long. You go, oh, let's go to, question 2. Guess what the correct answer? It was C, and so on. Oh, question 3, all the way down to question A. Maybe the correct answer, 8. Correct answer was A on 8. Ladies and gentlemen, each probability of guessing correct is 1/5. And these are independent of one another. In other words, yeah, whatever. So this, again, is a binomial situation, ladies and gentlemen. So if I said to you, I'm going to try to move all this down. I don't know what I'm going to do. I need some space. Let's try to move it all down, okay? We're going to answer question number 1 here. I'm going to move everything down. Because, ladies and gentlemen, we have all the information to use the binomial. Do you guys agree? What do we need? And it's 8. We got the various x values here. And then we have little p. Okay? So for question 1 now, using the binomial here, x is 0. They want to know what p of 0 is. Okay? We're going to go out to the nearest, thousandths again. So let's go to the TI, ladies and gentlemen. And I got the TI open. It's warmed up. What do I do? You guys tell me from yesterday. What do I do? Second distribution. Which one do I look for? Binomial. Which one's binomial? Is that A? Okay. Oh, look at that. 8 trials. Good. That's still 8. What's little p today? 0.2. What's the x value for the first question? 0. And let's paste it. This is p of 0. What's this to the nearest thousands? 0.16 what? 8. Good job. This as a percent, ladies and gentlemen, is what? 16.8%. So what we're saying is the chance you guess correct on no questions, you get nothing right, is 0.168, or you have a 16.8% chance of not getting any question correct just by guessing. Okay? And that's pretty bad, right? You got nothing right. You guessed on all 8 questions. You got nothing right. Yep. Okay, you guys with me on this? Pretty easy? Let's look at the next one. What's the probability you guess correct on 1? They're asking for p of 1. So now, what's the only thing you do in the calculator? Second distribution, go to binomial, change that to what? What's the value of x now? Is that 1? What do you guys get when you paste it? What's this? 0.33. Is it 5 or 6? 6, the nearest thousandths, ladies and gentlemen. So guess what this means, right? You have a 33.6% chance of guessing correct on one question. Only one, a 33.6% chance. What about guessing correct on 2 questions? I want to know what P 2 is. So what do you do with P 2? So we're going to go to the TI. Second distribution, binomial PDF. A, what's your x value now? 2, paste that in. What's the probability? 0.29 what? And what is that? That's a 29 point what? 29.4% chance you guess correct on 2 what? Questions. What do you guys think? Is that easy peasy lemon squeezy? Okay, but you guys already know what kind of questions do I like to ask? What am I going to ask you that's even better? Yes. Question 4. What's the probability, ladies and gentlemen, of at least what? 1 correct guesses? Do you guys remember yesterday? How do you represent at least 1 again? X is greater than or equal to 1. Do you guys remember the definition? What's the definition? 1 or what? Or 2 all the way up to what? P of 8? What should you use instead? Complement rule. Do you guys remember that? Use the complement rule. The complement rule. 1 minus the probability of the outcomes that are not what? Here. Okay, you guys okay with that? That's what you guys want to use. So in the TI, ladies and gentlemen, very simply put 1 minus second second distribution, go down to what? What's your value of x now? 0. Paste that in. What do you got? This is the probability of at least 1 correct guess. It's going to be what? To the nearest thousandths, 0.83 what? 2. So there's an 83.2% chance of what? Guessing correct on how many questions? At least 1. What does at least 1 mean? 1 or 2 or 3 or so on. Okay, do you guys see what I'm saying with this? The language is going to come up in here, and you got to be ready for the language. Next question. I'm going to say 5. What's the probability that there's, you guess, no more than what? I'll say no more than 2 correct guesses. Question 6. More than 5. Correct guesses, ladies and gentlemen. Question 7. Less than 2. Correct guesses. Okay. Question 8. I'm going to say, what about at least 2? Correct guesses. So I'm going to introduce language, and I'm going to ask you guys to work on these questions here, okay? This is a lot like what we did yesterday. You just have a different n, a different x, and a different little p, okay? So we're going to get out the clock, ladies and gentlemen, and we're going to have you guys try these out. See what you get, okay? Of course, we'll go over it. All right, let's see what you guys did here, okay? Remember, language and what? Process, okay? How do you represent the phrase no more than 2 correct guesses here? No more than 2. X, 2, what do we use? No more than 2. What is it? Good job. Less than or equal to 2. Outstanding, ladies and gentlemen. And then what is the meaning? Because we have to now write down the meaning. What does it mean to be less than or equal to 2, right? It could be 0 or what? Or 1 or what? Or 2. Okay, did you guys do this here? P of 0 plus P of 1 plus P of 2 now. All right. Okay. Second distribution, binomial PDF. We're going to start with 0, okay? It's already on 0. Good. Paste that in. Now go to what number? Do now 1. So x will be now what number? X will be what? 1. Okay. Paste that in. And then add what? 2. Is that right? And what do you guys get? What is this to the nearest thousands? What digit is in the thousands position? A 6? What does that digit to the right say? Yeah, add 1 to 6 and get what? 7. Is that true? So ladies and gentlemen, take a look. Probability, you have like a 79.7% chance that you'll get no more than 2 correct guesses. 2 or less. So this is how you handle some of the language, ladies and gentlemen. What does more than 5 mean? We now have to look at more than 5. What does that mean, more than 5? That means x is what? Is bigger than 5. Okay. Which outcomes are bigger than 5? 6. What else? 7. What else? You end at 8. Is that true? Because there's going to be only 8 questions. So, all right. Nice. More than 5. These are the outcomes that are more than 5. So you go to the TI now, and what do you say? Second distribution, binomial PDF. Start with what number for x? 6. Paste it. Plus second distribution, go down to what number? What's the next value of x? 7. Paste it in. And then we're going to end at what number? Where do we end at? We end at 8? Oops. That was 8. Okay. Oh, look at that. What's the deal here? That probability to the thousandths is going to be 0.00 what? 1. Good. This is interesting. Here's what I mean by that, right? Why is that so interesting? See, ladies and gentlemen, as a percentage, that's actually 0.1%. Is that right? Move the decimal 2 spaces to the right. That's actually 0.1%. That's smaller than 5%. What does that mean about this event? Note to self, make that a test question. What does that mean about the event? The event is what? It's not likely. Remember that? Any probability smaller than smaller than 5%? It's not likely to happen. It's not likely you're going to get more than 5 correct guesses. It's still possible. It just isn't what? Likely. Okay, so if getting more than 5 correct guesses means you pass, it's not likely you're going to pass by guessing. Okay, you guys see what I'm saying? This is how you guys use this information to make decisions. It is not likely you're going to pass. If passing is getting 6, 7, or 8 questions correct, and you got to guess in all 8, 5 parts, it's not likely you're passing. What do you guys think? Is that kind of amazing? Sometimes multiple choice tests could be very what? Difficult. Why do people do you guys like multiple choice tests? Some people like them. Why do you guys like them? Is there a reason? What do you guys think? Why do you guys like those multiple choice tests? Well, I think people think, oh, I didn't study, but I'm just going to guess. They think it's a good what? Format. But what I'm sharing with you guys is that if that's your game plan, not studying, even when you get the opportunity to guess, probabilistically speaking, it's not likely you're going to pass. So hopefully that makes an impression. You guys know what I mean? What about this? Less than 2 correct guesses. Smaller than 2. Okay, you guys see this language here? Less than 2? All right. Which outcomes are smaller than 2? What number is less than 2? What are they? Good. You see, guys, you guys see how the language, aren't you guys glad we worked on that language originally? I am. I don't know about you guys. I am. Hopefully it works out. Let's see. Second distribution. Go down to binomial PDF. X is 0. Paste that in. Plus second distribution. X is, go down to binomial. X is what number? 1. Paste that in. What do you got? 0. What? 50 what? 3. So notice this. In terms of probability, right? You got about a 50% chance, because that's 50.3%, of getting what? Less than 2 correct guesses. That's smaller than 2. There's a 50% chance to get smaller than 2. 0 or 1. Okay, you guys see what I'm saying? What about at least 2? How do we represent at least 2? X is greater than or equal to 2, is that right? 2 or more? What's the probability you get 2 or more correct guesses? What's the meaning of 2 or more? 2 or 3? All the way up to what number? 8. Oops, I want to cut this. One minus what? P of 0 minus P of what? 1. See this here? What do we call this? Complement rule. One minus P of 0 minus P of 1. So go over here now and use the TI. So we say 1 minus second distribution binomial PDF. The X value is 0. Okay. Paste that in. Minus second distribution. That's going to be now P of 1. So your calculator really is doing all the work. Is that true? It's doing all the math. And that's also approximately what? What is this? 0. What? 497 to the nearest thousandths? So, your calculator is doing all the work here, ladies and gentlemen. There you go. And I want you guys to note something here, okay? What's the probability you guess correct on, I'll say this is like question 9, all questions. You're guessing correct. What are they saying? They're trying to say you got 8 correct guesses. 8 out of 8. So X is 8. Because that's true for all 8 questions. So you imagine if you thought, you know what? I'm going to ace this exam just by guessing. You think you're going to get all of them correct by guessing? It's possible. Let's see the probability of it. They're asking for P of 8. Second distribution. What is your X value now for all 8 to be correct guesses? X is what? 8. So, ladies and gentlemen, what is this? We're going to have to talk about this. Anybody know what you're looking at here? Let's see if you're awake. I'm going to copy everything I see here. This is going to be a question people need to answer. What does that mean? What are you guys looking at? Do you guys know? What is this? This is scientific notation. Scientific notation, what that means is take the 2.56, okay? Move that decimal how many spaces here? You see this number here, -6, right? That's really code for times not e, it's times 10 to the negative 6. So you take the decimal point, and because the power for 10 here is negative, you got to move the decimal how? How do you guys move that decimal? 6 spaces to the what? To the left. So you go 1, 2, 3, 4, 5, and 6. That decimal moves 6 spaces to the left. What do you do with the blank spaces? You fill them in with what? With zeros. So this answer is really 1, 2, 3, 4, 5 zeros, 2, 5, 6. Okay? Because they gave it to you in scientific notation. However, what did they say to approximate to? Tenths, right? What's the approximation? Tenths, hundreds, what? Thousands. So the digit here in the thousands position is 0. Look at the digit to the right. That's 0. You know what this is approximately? This is approximately what? 0. That doesn't equal 0. That's approximately 0. That's close to 0. So again, that probability is smaller than what? 5%, just so you guys know. So this is close to 0. It means it's not likely you're going to get all 8 correct. It's not likely to happen. So don't go into a quiz just what? Guessing. Okay? Now, compare that to the following. I'm going to say, compare this to this question here so you guys know. What about a 7-question true-false quiz? What's the probability of question 1? More than 4 correct guesses. Okay? I just changed this whole idea on you to compare and to what? Contrast. Compare and what? Contrast. Now, this is a binomial again. And tell me if you guys know, what is n going to be here? 7. Good. Okay, what is your x going to be? Number of what? Correct guesses. You say, Mr. Judge, how do I know? It is always in the what question? So more than 4, well, that's x greater than 4. Is that true? Easy peasy? And what's the probability of a correct guess? Let's see if you're awake. For a single trial, we needed to get little p. Is that right? What is little p? You can either guess correct or you can guess what? Incorrect. This is for a single trial, one trial. Okay? What's the difference between a multiple choice quiz, or I should say a multiple choice question, and a true-false question? What's the probability you guess correct on a true-false question? Anybody know? True-false question. Yes, good job. Isn't that 1/2 for each? Is that true? You say why? Because there's only 2 answers, and one of them is what? Correct. Good. This is back to being equally what? Likely. So little p again is that 0.5 now. That little q is also 0.5. Equally likely. Just like having children or flipping a coin. So your little p, ladies and gentlemen, is 0.5. And so, yeah, we can now use the TI to answer the question here. Okay, we have n. What is n? 7. What is x? Well, let's write down what x is. The probability that x is greater than what number? 4, more than 4. Which outcomes are more than 4? 5. What else? 6. What else? 7. So let's make sure we enter everything correct. Okay? All right, here we go. Second distribution. Go to binomial PDF. Okay. Trials are 7. Little p is 0.5. We got to change that back. The value of x, the first value is 5. You do 5, 6, and 7. Add that to the second probability. X value is now what? Is that 6 now? Paste it. Plus second distribution. What's my x value now? Do you guys know? What did I do? Distribution, binomial. X value is going to be 7. Is that true? Okay, because we're trying to do what? We're going to try to add p of 6, or p of 5, sorry, plus p of 6 plus p of 7, because these are the outcomes that are greater than 4. Okay, hit enter now. And what do you guys get to the nearest thousands? 0.22 what? 7, ladies and gentlemen. Easy peasy lemon squeezy. Can you guys compare and contrast the different quiz settings? I like those questions because they're just so relevant to students. What's probability you get at least what? 5 correct guesses. 8. More than 2 correct guesses. Should we give you guys some time to do this yourself, or should we do it together? Should we do it together? How do you guys represent at least 5? X greater than or equal to 5, is that right? So which outcomes are greater than or equal to 5? P of 5, P of 6, what else? P of 7. I think I know the answer. Anybody know why I know the answer? See the last example. More than 4 is the same statement of at least 5. Okay, is that true? You guys okay with that? More than 4 means at least 5. Same answer. Prior answer. What about more than 2? What does that look like? X is greater than what? 2. So which outcomes are greater than 2? 3. What else? 4. What else? 5. What else? 6 all the way up to 7. Is that true? Isn't this by definition? But you know what I would do? Why would I use the complement rule? Shorter. Good. Use the complement rule, ladies and gentlemen. What is the complement rule? You might say, I don't know what you did. It's always 1 minus the probability, or probabilities, in this case there's more than 1. 1 minus the probabilities that are not in the definition. So what is not 3, 4, 5, 6, or 7? What is not there is P of 0, P of 1, P of 2. So the complement rule is going to be shorter. And if it's shorter, that's what I'm going to do. Okay, you guys see what I'm saying? 1 minus second distribution binomial. What's my first x value? It's going to be what? 0. Minus second distribution binomial. What's your x value now again? 1. Paste that in. Minus second distribution. What's that x value going to be here? 2. Is that right? Paste it. What do you guys get? 0. What? Yeah, 0.77 what? 3, ladies and gentlemen. And this here, by the way, is really about 77.3%. So this is a 77.3% chance that you'll get more than 2 correct guesses on this true-false what quiz. 2 outcomes, true-false. Okay, what do you guys think? Is that okay? Easy peasy lemon squeezy. So let me say something here. If I go to my website, 227, you know what we just kind of went through is a couple of things here. I think I have to give this to you guys here. Yeah, I got to kind of update your homework, I think. Yeah, it's statistics lecture 9, which is probability distributions and expected value, 9 and 10. So if I go back here to the assignment portion, we got to add homework number what? 3. You can't really do them all yet, but you know, so if I go through and take a look, maybe I could be a little bit more specific, and that might be helpful because you guys have spring break. And hopefully you guys do homework during spring break because it's important. I'll do 1 to 8. Oh no, I can't do 1 to 8. Nope. Take 1 to 6. And you guys do have solutions. You guys know that? Where are the solutions at? So hopefully you guys do some work during spring break. Some people complain, I don't do, you give me homework during spring break. And I'll say, well, yeah. Look at 1 to 6 as well, actually. Huh. Okay, we do 1 to 6 as well. Um, but what I'm going to do here too is because sometimes people just aren't aware. I'm actually looking at the browser here for some of you guys at home.